Okay, you are watching section 2.4 in geometry. The objective is use postulates and diagrams. Use postulates and diagrams. Now you may want to be in your book just to follow along, and that would be on page 96. And you can pause whenever necessary. Okay, postulates. These are statements accepted without proof. That's important to know that without proof are postulates. These are like baby statements. Small statements we make that don't have to be proved. So we accept them without proof. Statements that are proved, that must be proved, are theorems. And we are going to be doing proofs during geometry class starting this chapter. And when you make a proof, you are going to have to use postulates, definitions, properties, anything that you can state as a fact. And so it's a deductive setup. A postulate is one part of a proof. Okay, so statements that are proved are then called theorems. Now all these postulates that we're going to go through could be used in a proof. And the first couple are ones that we already know from the first chapter of geometry. So the ruler postulate is if you have a segment, let's call it XY, and you had a ruler lined up to it, and you had corresponding numbers to those coordinates X and Y, you could find the length of that segment when you take the coordinate that's associated with X and subtract it from Y. You'd get the length. So in this case you'd get 1 minus 3, but notice this is in absolute values. That negative 2 inside the absolute values becomes a positive 2. So that's how your ruler postulate is. Basically you're measuring something, and we kind of broke it down into too much detail maybe. Alright, segment postulate, you know this one already. If you have a segment and it's a segment A, B, and then a C, B does not necessarily need to be the midpoint. It's just a point between A and C. Here's what you can conclude, that the length of A to B plus the length from B to C equals the length from B to C. So another way to look at it as the segment AB plus the segment BC is the length of the segment A. I wrote that wrong. Is equal to the length of the segment AC. So part plus part equals the whole. Not too big. Okay, number 3, postulate number 3. So this is considered postulate number 1, number 2. Now we're at number 3. Postulate number 3 is a protractor postulate, and if you have an angle, and let's say that this ray is associated with this value of X and this one the value of Y, and you have a protractor lined up. Here's the whole of the protractor, and here's your arc. What you have then is the angle measure that's associated with X. You can subtract that from the angle measurement that's associated with Y, and then you have your angle measure. So if X was 70 degrees and you're subtracting, let's say Y was matched up with 0 degrees, then you have an angle measure of 70 degrees. Now it doesn't have to be that Y was down here. It could be that Y was associated with a point up here, and then you'd maybe have 70 degrees minus the Y is associated with a 50 degree mark, and when you subtract those it's 20 degrees. So that would be the measure of that angle formed. Alright, angle addition postulate is just like segment addition postulate, and this ray does not have to be the angle bisector. So now I'm naming this angle A, the large one is A, B, D. The ray interior in the interior is C, ray BC. So if I took angle ABC plus the angle I'm sorry, this should really say measure of the angle ABC plus the measure of your angle CBD. That would equal the measure of the complete full angle ABD. So if you add the two measures up, you get the big angle. Alright, those are all reviews. That would be postulate number 4. So today what we're doing is we're coming up with these other postulates, and these are baby step ones, just like the others. So this is line postulate, saying through any 2 points there exists exactly one line. Through any 2 points there exists exactly one line. That's strong vocabulary, exactly one line. And that makes sense that every time I have any 2 points, determine a line. Now there's an infinite number of points on the line, but it starts with any 2 points. You can play dot to dot, and when you connect them, it's a line. So that's postulate number 1. Through any 2 points, there's exactly one line. Postulate number 6, you don't have to know them by their numbers, but I'm just kind of organizing what we've learned. Postulate number 6 says, let's see, this is actually line postulate number 1 over here. This 5 shouldn't be there. Line postulate number 1 is through any 2 points there's exactly one line. And line postulate number 2 is what we're doing next. And that says a line contains at least 2 points. A line contains at least 2 points. So it's the reverse of really line postulate number 1. So if I were giving you a line, you know it has at least 2 points, but it's an infinite number of points, but at least 2 points. But in line postulate number 1, if you have 2 points, then you have a line. In line postulate number 2, if you have a line, you have at least 2 points. Okay, next is the postulate number 7. It's line intersection postulate. It says if 2 lines intersect, then their intersection is exactly 1 point. If 2 lines intersect, then their intersection is exactly 1 point. So picture is good. Draw your 2 lines. You can lowercase script, this is line L and this is line M. They intersect at exactly 1 point. Let's call it point A, capital print point A. Okay, line postulate, or sorry, plane postulate. This is postulate number 8. I don't know why these are coming up this number this way, but this is postulate number 8. Through any 3 non-collinear points, there exists exactly 1 plane. Through any 3 non-collinear points, there exists exactly 1 plane. So if I have 3 non-collinear points, 3 points that don't form a line, I can form exactly 1 plane containing those. Okay, next is postulate number 9, and this is the plane postulate. And the plane postulate says a plane contains at least 3 non-collinear points. A plane contains at least 3 non-collinear points. So it's the reverse of postulate number 8. If you have a plane, it contains at least 3 non-collinear points. It has an infinite number in there, but the least it has is 3 non-collinear points. Okay, postulate number 10 is the line in plane postulate. Says if 2 points lie in a plane, then the line containing them lies in the plane. If 2 points lie in a plane, then the line that contains the 2 points lies in the plane. Okay, not a whole lot of room for a picture, but here I have 2 points are lining in a plane. Here are my 2 points, and here's my plane. If I have 2 points, there exists a line. That line also is going to lie in this plane. So if 2 points lie in a plane, then the line that contains those 2 points lies in the plane. Not a big step here. Okay, for postulate number 11 is plane intersection postulate. Says this: if 2 planes intersect, then their intersection is a line. If 2 planes intersect, then their intersection is a line. So think of 2 walls in the classroom, and I'll try to draw this. But you have, here's one wall. Now another wall is coming in. Let's see, maybe another color will help. If I draw this off in the distance here, it's supposed to be dashed. Let me try again. It'd be good to give you a better example. So here's one plane. The other one needs to be angled off. Here's their line of intersection. And then if I go back, and I should dash this back one and make the front solid. Okay, well, the intersection here, hopefully you get the idea. 2 planes are intersecting, and like 2 walls, and it creates the corner of the room, which represents a line. Alright, there's a definition I want to go through, and that definition is of perpendicular lines. If a line is perpendicular to a plane, then it is perpendicular to every line in the plane at the point of intersection. Okay, so saying if a line is, here's your symbol for perpendicular, if a line is perpendicular to a plane, then it is perpendicular to every line in the plane. Then it is perpendicular to every line in the plane at the point of intersection. So here I have a plane. Here I'm going to have my line L, and I'm going to make it perpendicular to the plane. Well, then it's going to be perpendicular to every line in the plane, like M and N and K. All of the lines will be perpendicular at the point of intersection. Okay, we'll go through a diagram on the back for this part 2 of 2.4.